Sirat Derek, who has been with us now for more than 5 years, working across 3 continents as the SME for cloud native development between Turkey, Middle East, and Europe as well. My name is Ayman Al-Sheikh. I'm a senior manager for the solution architect. I've been with Red Hat for more than 10 years, advising customers and C-level and architects and sometimes developers about how we can adopt open source strategies. Today, this is one of the sessions that we're going to talk about cloud native applications. This is the first one in a series where we believe that because of the importance of that topic, that in the coming years, everybody was talking about cloud native development. How can we modernize our existing applications? We believe that there is a lot to add in this area, and I'll be delighted to talk about that today with you. To do some kind of a quick introduction, and then I will hand it over to Sirat. With no further ado, let's start. For the agenda for today, we're going to talk about introduction to cloud native development. What does it mean? The architecture principles behind it, and the business principles around it as well. And then we just quickly introduced the Red Hat Runtimes. What does it mean? What's the Red Hat strategy for adopting cloud native, and what does it mean to us? Then I will hand over to Sirat. He will talk about what does it mean in terms of caching, messaging, single sign-on, service mesh. There is a lot of people talking about service mesh and Istio. What does it mean in details? How are we helping with the tooling? Because we are very keen on providing comprehensive tooling that can help the developers. Talking to developers is the key nowadays. And with the CodeReady workspaces, we did acquisition a couple of years back, and then it's integrated within the platform of OpenShift. We talk about CI/CD and the capabilities integrated within the platform, and how can we have different options, moving the applications between different environments, and what does it mean in cloud native and especially containers nowadays. And then we'll go for a demo, and shortly we'll have an interactive Q&A sessions for 5 minutes, where you can post your questions and we'll answer it. Feel free to post the questions while we are during the presentation, and we will respond as well over the chat within the platform. Today, it's all starting with the customers. How the customer experiences and the customers were expecting from us made a big difference in the way that we behave. The customers are expecting that we have an on-demand service, that everything is like on demand with a click of a button and has to be very responsive. That's why the universal user experience, the UX, is quite important right now. Other than that, you lose the customers. There is some kind of interaction with a level of personalization experience, that everybody has to personalize his capabilities, and the platform itself has to be smart enough to provide whatever I prefer via the user interface, and the customer journeys are the kings. That's why we have a lot of projects that I'm sure that you have been all part of it, which is like the omni-channel, the universal channel modification, so that everything is abstracted. And along as, if you talk about the classification of the systems nowadays, we have got we used to have a classification about systems of engagements, system of records, and systems of innovation. And systems of innovation and systems of engagements are becoming more about the systems of differentiation. Talk about the capabilities that I've got as a business analyst, analyzing the capabilities of a certain company. But the differentiation is no longer about the systems of records. Systems of records are becoming like a commodity. They can become in the SaaS. They're quite important unless you are a provider of that. If you're the SaaS provider or the back-end provider of a payment gateway. But other than that, the way that you interact with the customers, the way that you think, providing new services, which is systems of innovation, and there is a big difference between systems of innovation and systems of record, because systems of innovation, you don't know exactly what you need to do, while a system of engagement is like a portal, like a mobile application. A system of record is something like the ERP. With the systems of innovation and systems of engagement, they're becoming the differentiation and the de facto standard right now, where everybody wants to bring this capabilities in-house, and where we can talk about why development is becoming that important. And if you talk about that statement, I think it's not that new. All of you are aware about it, and we have to be proud about it. Every company is becoming a software company. And this is not a quotation that's coming from Ayman Al-Sheikh. It's coming from everybody, like Mercedes-Benz right now. They're talking about our differentiation right now is not becoming the hardware. It's not about the machine itself. It's about the lines of code that we are having in our smart cores. It's our differentiation against them how can we behave, how can we do things differently, how can we interact with the user interface within the car. It's the experience. I've got a lot of things like that. Talk about autonomous cars. If you talk about even the Amazon, like you don't have to be born in the cloud to have the systems, which is like custom development. But custom development and software is becoming the king in terms of software development. I have to have my tailored software. Not everything is ready-made. Things are like have to be custom made for my business, and because this is the like secret sauce for success. And there's millions of examples and of that. People are becoming a software company, not that they're selling software to make their money, but the software is becoming pre-integrated and an important part of what we are offering as an end product embedded within it, so that it can show the differentiation in so many different things. And we have examples from different industries. The other thing is about what would they call it because of that. What is the consequence of this? It's like IDC and Gartner and so many analysts are talking about the explosion of application development, the number of applications that has been there. So IDC is predicting more than 500 million of new logical applications to be developed between 2018 2023. And this is equivalent to what we have been done in 40 years. And if you talk about that the information is doubling every 2 years, that makes a lot of sense right now. That's why of the things that we are keen to learn how to develop and make our kids learn development and have us an intelligent company and intelligent enterprise developers is becoming better. The other thing is like mission critical applications, 40% of them are becoming custom development as well, as per moving next, it's like, but what does it mean, like cloud native or cloud? What are the new application development characteristics? Here are a lot about cloud native. Here are about like technologies like CI/CD, containers, APIs, microservices, hybrid cloud. These are like, it's technologies plus architectural principles that we have to be keen about it while we are developing our application. And choosing the right set of products and technologies is quite important because it's like, shall I do it myself? Shall I be going to the public cloud to develop everything in one platform? What kind of strategy that I should be adopting? Is it like having CI/CD alone and containers alone and Kubernetes at some point of time and microservice? That does it mean that I'm agile? I'm doing everything? I think it's a combination of different things. It's technology, people, and processes. The culture with the people, the technology itself, which is talking about, and the processes, which is the agile processes or the DevOps processes, which we're going to talk about. But how cloud native and platforms are different. That's an important thing. It's a developer's view, and here we need to spend some time about like can be seen as a maturity level between different aspects of what we have seen here in the y-axis, like applications, operations, portability, development tools, and you can move within the journey. There is nothing which is like, yes, I have to be. Everything has to move all of a sudden from virtual to cloud. You can have a combination, and this is one of the things that the analyst has been saying as well for a long time, that yes, it's not all about cloud native. It's not all about like it's a combination between the transformation of modernization of the existing and having new ideas built in the cloud native. But if you talk about application runtimes, it's moved into from physical infrastructure from physical to virtual to the cloud, like mainframe Unix, VMware, Hyper-V to Kubernetes, OpenShift, and public cloud. Application runtimes, they will mono, they will terminal, the message-oriented middleware. Now they move to SOA, stateful application servers and middleware centric. Now we're moving about polyglots. That's quite important. Distributed microservices and mini services. It doesn't have to be all microservices. We talk about mini services, event-driven, serverless, operations. It was manual and heavy to have a semi-automated with virtualization. Now it has to be fully automated, like self-healing systems, automatic provisioning. All of this has to be built in within the platform that you have adopted. Development lifecycle, it was manual, waterfall. Now then it moved to waterfall and semi-agile, and we have continuous integration. Now we have continuous delivery and agile and DevOps. Packaging, it was like very platform specific, and then we moved to jars, wars, ears, stuff like this. So in Java, it has horizontal scalability and mainly vertical scalability. Now we have images which can run anywhere. They are portable. They can be mainly horizontal scaling than vertical scaling, and this is what we can think about it. And as I mentioned, it's like a maturity level. You can think about where I am, and then you work on a plan to move, typical to the business case where you adapt to. Developer tooling, manual testing, automated testing based on local IDEs. Now it's full mobilization, run everywhere, fully automated testing. It's like the testers has moved from just writing automated normal unit testing to the full testing, which has to be automated based on the tools. The final thing is you think about is the cost for failure or cost for innovation. I have this expression about failing fast. This had never happened without being in cloud. It was very expensive and then moved to be a bit expensive with the waterfall when I started my career, and now it's like, it's very low. When you do your first iteration, you can move quite quickly. But to do that, to do this architectural principle, there has to be an innovation model to keep with the pace of the business change. The business change has been there for, and now it's quite significant and is going quickly. We don't know what the customer wants. We have to have a sense and respond kind of things. We try and add features or modules, and then we can roll back. That's why we can fail fast, or we can increase whenever we have seen that with things like feature toggling. We have seen all these nice concepts. And to do that, we have a definition of cloud native. It's the lean implemented applications utilizing the capabilities of the platform using agile and DevOps practices to create, whether it's microservices and mini services in a container platform or running on top of any cloud infrastructure. For interoperability between the cloud infrastructure, whether it's physical, virtual, public cloud, and now even at the edge, that's one of the keys. That if you are logged into one of the public clouds, that's not a cloud native. That's like, yes, you're developing for a certain platform. You have to think about that portability. That's quite important. One of the concepts that we were very keen about it in Red Hat, and we will touch it when we talk about OpenShift. You have to think about cleaning in a code way. It has to be API specific and write once and run anywhere. That's why I was very, very keen about talking about hybrid cloud, whether it's private, whether it's public, whether it's physical, or even in an edge. Moving to the next part. Yes, before cloud native, I will not spend much time talking about that, but you can find that people are like the life cycle was in months. It is not in weeks. The cost of failure was very, very, very difficult. The product owner, it has like it was a waterfall. You cannot add features quickly. Whenever there is a change coming from the customers, it was quite a problem. But right now we have to think about the economics of the cloud native development. And thinking about the economics of the cloud native development, then it's basically, there are a lot of studies that can help us to do that. And 50% of the people, it's faster in deployment, 40%, 45% improved scalability, and 42% of the cloud native portability. And there is so many business cases that we can work together with the customers to present it and to talk about. But there are like tangible benefits that we can get out of adopting cloud native. But how did we respond to Red Hat? That's quite important. And then like providing a full platform, which is Red Hat OpenShift. It's like a container platform that you can run your next generation application, cloud native application on top of it, having a very portable, lightweight, cloud friendly, cloud native Red Hat full middleware, because it's not thick by nature. It was implementing all the techniques of lazy loading, and it was lightweight by nature. And then we were one of the few vendors who were able to adopt it very quickly, and then developer experience via the CodeReady via the tooling. Today we are focusing on the cloud native development. We're going to talk a lot about the OpenShift platform. I just will cover it in the next slide, and we might sometimes talk about CodeReady again, which is how can we have an IDE born in the cloud to help you fully. The OpenShift, it's not only Kubernetes, because everybody's talking about like, yes, if I have got containers and Kubernetes, then I have got everything that's needed. I have a container platform that's supporting everything. No, there is a lot of things that is needed. It's plus, as you have mentioned. You have to talk about automation, automated operations. How can I have a monitoring? How can I have show back? How can I have a logging? How can I have the clustering services? How can I have CI/CD? And if you can talk about like it's from a CAS to a PaaS to a function as a service, along with the developer experience. And as I mentioned, the key is the interoperability, and there is no lock-in, so that you can give you the choice to run wherever we want. And this is what we call the open hybrid cloud strategy that we are adopting, and we have been working on it since 2013. We are one of the very rare vendors was working on that, where everybody was talking about everything going to be public, everything is stay private, and we're working on that, and we have all the tools to support this. And within the cloud native, we gonna talk about middleware, application services, and service mesh. The Red Hat middleware is mainly three pillars: the runtimes, the integration, the process automation. And the runtimes, you have got the OpenShift runtimes, application runtimes. We're going to focus on that today. Data grids, OpenGDK, message broker. This is bundled with the runtime integration, whether it's Fuse or AMQ, and process automation and the rules engine. And now, to talk about applications in the cloud, they will have the same requirements that we have. Runtimes to run the polyglot requirements that you have, integration to integrate, whether it's going to be monolithic applications to be integrated within the cloud or the new microservice to be integrated in the cloud. And we'll talk about the developer-centric integration, the citizen integration. That's why we have modernized all of this stack to be running on the cloud and to be cloud native as well, and process automation. But the same pillars that we're working on, we have been working hard in the last years, and we have a full, ready, comprehensive stack that can be running on as cloud native when it comes to the whole middleware. Back to the runtimes, and this is where we have spent a lot of effort, and this is we have a lot of differentiation. We are coming from developers. JBoss was developer friendly, and we continue to do that with the support of different things. The developers working with developers there have to have a polyglot support. They have to have a cloud native lightweight kind of runtimes. They have to support the runtimes coming from different open source vendors as well, or open source communities, whether it's going to be reactive, whether it's going to be serverless. This is where we're working so hard to have all of these supported within the Red Hat runtimes. OpenGDK, serverless, Quarkus, where we're going to talk about Quarkus a lot, which is going to support serverless, microprofile, reactive via Vert.X, Spring Boot, Open Liberty, which is quite important as well, with the new specs of GE, JavaScript, along with SSO, data grid, message broker. And today we're gonna talk about that within the next session, within the session. And with that, I will hand it over to Surat, who's gonna take us to the next part of the presentation. Thank you very much.
Thank you very much, Ayman, for this wonderful presentation. Hello, everyone. Thanks a lot joining us today. My name is Hat Runtimes, and I do work as Senior Solution Architect in Red Hat MENA region. I would like to start my presentation with how traditional application servers development and deployment models are changing. There are still a lot of existing enterprise applications hosted by application servers today. Application servers are a reliable way of empowering your business logic code with extra capabilities such as clustering, scalability, and security. On the other hand, application server-centric traditional development and deployment models has its own limitations such as scalability, flexibility, and longer delivery cycles compared to cloud native. Cloud native is replacing those models, so it's essential to understand how do we replace those application service provided capabilities in the cloud native world and also enrich with additional capabilities. In the cloud native world, capabilities are decomposed into several parts. We don't expect that one magical middleware solve all of our problems anymore. The first important part of this transition is the container platform itself, which is our new target deployment platform. The container platform abstracts operating system capabilities on a multi-server cluster. Infrastructure-related capabilities handled by the platform, including resource abstraction, resource sharing, networking, etc. In addition to infrastructure-related capabilities, the OpenShift container platform also replaces and extends some of the traditional application server capabilities in many ways. Application building, packaging, deployment, release management, scalability, load balancing, lifecycle management, failover, configuration management, logging, monitoring are just some examples of capabilities provided by the container platform. There are also service-oriented building capabilities such as service registry, service discovery, load balancing, service routing to design and implement your solutions. So these are just few of the reasons why we are captivated by power of Kubernetes and eager to migrate our workloads on the platform. Most of these capabilities are gained as declarative capabilities and do not require developers to do anything at all on their source coding side. More importantly, these capabilities are not specific to a certain set of application runtimes. You can use any programming language and runtime for your services and gain the same benefits. The platform provides all of these great features in application runtimes agnostic way. However, the application itself and runtime supporting that application is still the most important piece of the puzzle. We can't simply expect that having perfect improvements as just shifting our existing application with bulk runtimes into the container platform. Whether you migrate your existing applications into container native or implement a new one from scratch, having a cloud-adapted runtime and middleware is crucial because of a lot of capabilities are now fulfilled by the container platform and expected capabilities from the runtime are narrowed down around core business logic implementation. It's possible to implement solution with lean runtimes having the same enterprise characteristics as application service and beyond. If you think about it, this is a huge change in enterprise solutions area, opening us doors of a broader set of runtimes and frameworks usability, and gives us a greater flexibility to design and implement our solutions with multiple runtimes and frameworks. That's why Red Hat Runtimes provides a bucket of runtimes and frameworks instead of a single application server technology. Application servers also consist of some complementary capabilities such as caching, messaging, and security to form an enterprise solution. Now, decomposing your monoliths into smaller pieces, you will need these capabilities in a shared manner accessible from your services. Red Hat Runtimes consist of Red Hat Data Grid as distributed caching, event sourcing, and in-memory database solution. Red Hat AMQ Broker for asynchronous patterns implementation with rich protocols and client support is there. Red Hat Single Sign-On for application security and also for sharing and provisioning the user context in between your application services, also the part of Red Hat Runtimes. So in summary, many of those enterprise capabilities we've seen in application servers and more now comes built in with OpenShift Container Platform. You can implement your solutions with lean runtimes and frameworks. Required complementary capabilities now available as shared capabilities in the same container platform as part of our Red Hat Runtimes offering. There is also design, implementation, migration, and continuous delivery part of this story. Red Hat Runtimes and OpenShift includes developer tools and services, CI/CD engines, and a migration tool. So, as we said, Red Hat Runtimes consist of several Java and JavaScript runtimes and frameworks, but we have very limited time today to get into details of each one of those runtimes. I would like to talk only about Quarkus for a minute, as that's the most recent family member of Red Hat Runtimes. Quarkus was born to address Kubernetes native development needs. Quarkus does not target monolith applications at all. It's really targeting microservices, serverless, and event-driven architectures. When the Quarkus project started in 2019, it was a collection of experts from different popular open source projects that are commonly used in the traditional native, cloud-native Java stack, including Vert.X, Hibernate, REST Easy, Eclipse Macro Profile, Wildfly, Undertow, OpenJDK, and we asked them to help to optimize their framework for Quarkus. The main difference between the traditional cloud-native stack and Quarkus is that Quarkus is optimized for running in containers and moving a lot of dynamic behavior from runtime to build time. Quarkus uses a technique called compile time boot to gain speed and drop memory requirements. This provides a stack starts in milliseconds and highly optimized in memory usage. Taking advantage of GraalVM, the Quarkus native compiler can create small and fast native executables. This can be run locally and really excels when used in a Linux container. In this way, you get even more speedy applications that perfectly fits in serverless application scenarios. The coding syntax of Quarkus is very familiar to Java Enterprise Edition developers, so they can easily shift to Quarkus coding with a very minimal learning curve. With the recent extensions to Quarkus, Spring Boot developers can also shift to Quarkus using the same familiar annotations they are using in Spring Boot. Live coding capabilities makes Quarkus a joyful development runtime for developers. Developers can use their favorite IDEs like Visual Studio Code, Eclipse, IntelliJ, and see their coding change live in action. Quarkus has a reactive core that supports the traditional imperative model, reactive model also, or both in the same application. We have optimized approximately 50 frameworks, both for JVM and native mode, and over 90 extensions are available. It's really growing exactly as intended. When you break the monolith to smaller services, you get a lot of them, and as the number increases, the complexity of communications between these services increases as well. What used to be an internal call from one piece of code to another in the monolith is now an API call over the network. It means we are relying a lot more on the network characteristics than we used to do. Dealing with this service mesh complexity requires some additional capabilities to be in place, such as resilience and fault tolerance, visibility and reporting, routing and traffic control, identity and security, and also policy enforcement. A service mesh is a layer that manages the communication between the individual services that work together as an application. The routing rules and communication security can be managed by the service mesh instead of being hard-coded into the application code or manually defined. This is critical when application scales and you have hundreds or thousands of services working together. A style service mesh is logically split into a data plane and a control plane. The data plane is composed of a set of intelligent proxies deployed as a sidecar that mediate and control of network communication between services. It's deployed exactly in the same pod as your application service deployed. The control plane is responsible for managing and configuring proxies to route traffic as well as enforcing policies at runtime. The control plane is composed of three components. Mixer is responsible of enforcing access control and usage policies across the service mesh and collecting telemetry data from those proxies deployed as sidecars. Out is managing services to services and end user authentication. Pilot, which is the third component, handles the traffic management capabilities for intelligent routing such as A/B tests, canary deployments, and also provides resiliency such as timeouts, retries, and circuit breakers. The OpenShift service mesh is based on Istio, but it's also packaged with Jaeger and Kiali to improve the observability and control of the service mesh. Jaeger is a tracing tool that is used to visualize some of the performance of an application, where Kiali can be used to provide a topology view and control of the service mesh. The topology view can be critical for developers to understand how the application comprised of macroservices. Beyond the topology view, you can observe your service mesh health, traffic, error rates, and tracing through embedded Jaeger screens in Kiali. Service mesh configuration can be done on Kiali screens too. All right, Let's talk about OpenShift serverless for a minute. Reddit defines serverless as a computing execution model that depends on services to manage server-side logic and state, where business logic run in stateless event-triggered compute Linux containers. Long story short, some service send an event. OpenShift publish events through an event broker. Defined triggers send those events to targeted services. Meanwhile, your events triggered service scales up, process the event data, and scales down to zero again. OpenShift Serverless is based on the open source project Knative, one of the fastest growing serverless project in the market today. This ensures that you don't lock in to a proprietary technology, run on hybrid cloud, and benefit innovation from a growing open source community. OpenShift Serverless enables almost any containerized application to run serverless. That means you can choose any programming language of your choice and enable auto-scaling behavior, scaling up to meet demand and down even to zero. However, it's best to choose speedy runtimes, ideally one runtime that can start in milliseconds, low on memory, respond quickly, and shut down quickly. Beyond auto-scaling for HTTP requests, you can trigger those serverless containers from a variety of event sources and receive events. Kafka messages, file upload to storage, timers for recurring jobs, and more than 100 event sources like Salesforce, ServiceNow, emails, etc. That powered by CamelK can be used as an event source. So we talk enough about runtimes, middleware, and the platform itself. Let's briefly take a look at the developer services. It's all great to have cloud-native runtimes and platform, but it all starts with developers. It is developers who are coding, building, debugging, and testing those digital services before they commit it to the source base. We call this inner loop. The toolset for the inner loop has a direct impact on developers' productivity. Let's take a look at what developer tools are included in OpenShift and Reddit runtimes. OpenShift Web Console provides two perspectives, as one for administrators and another one for developers. In the developer console, applications-centric dashboards showing the topology, monitoring, and developer operations also can be easily accessed. OpenShift comes with different command line interfaces. Both kubectl and OpenShift's main command line interface OC can be used for all operations. Another CLI, OpenShift to Odo in short, can be also used for fast and easy to use developer-centric operations. Odo allows developers to concentrate on creating their applications without dealing with administrative things. Creating builds, deployment configurations, service routes, and other OpenShift container platform elements are all automated by Odo. CodeReady Containers is a single node OpenShift container platform running in a virtual machine on a developer's laptop. Developers can use their corporate OpenShift clusters for any development or test activity if they have a connection. But CodeReady Containers is a convenient alternative building and testing services while there is no connectivity to corporate clusters. CodeReady Studio is our long-term Eclipse-based IDE, which provides all required plugins for developing applications for Reddit runtimes and middleware. It consists of plugins directly connecting to OpenShift clusters and executes developer operations. Visual Studio Code is quite popular in the market. and preferred by many developers today. Red Hat published a rich set of plugins including Java, Quarkus, OpenShift, Kubernetes, CamelK for Visual Studio Code. Red Hat CodeReady workspaces falls in a special category in those IDs. It is a next-generation web IDE that makes cloud-native development more practical for teams. It uses Kubernetes and containers to provide a consistent, pre-configured development environments. Developers can write code, build it, and test it in containers running on Red Hat OpenShift container platform without any local setup. The user experience is really fast and similar to working on a local laptop. It has Visual Studio Code extensions compatibility. So reset of code extensions exist, including OpenShift one. It comes with 18 stacks, workspace templates, including Java, .NET, Spring Boot, EAP, Go, C++, Node.js. A workspace template is a set of container images that your developer tools, application server, database, command line tools are installed, and also commands are defined. Creating your workspace templates is also pretty easy. Once the developer finishes tasks in his inner loop, he commits the source code to shared source repo, and developer outer loop starts. That developer outer loop consists of several tasks, including building the source again, integrating it, testing it through several stages, deploying it to several stages again, executing some acceptance tests, security tests, and finally it turns out to a shippable product. These outer loops managed by continuous integration and continuous delivery engines depends on your corporate strategies. You can have continuous delivery or continuous deployment. You may prefer to have some manual steps before deploying changes to production systems. That's called continuous delivery. And in some other cases, you may prefer to deploy your changes directly to production system in an automated way called continuous deployment. So again, depends on your corporate strategies. You may have one or multiple pipelines. You may prefer to separate continuous integration from the continuous delivery part. OpenShift provides two CI/CD engine alternatives, Jenkins and Tekton. Jenkins is the most commonly used CI/CD engine solution in the market today. It has two parts as master and slaves. Master is a controller plane. You can deploy it through OpenShift catalog with some few clicks. Slaves are the builder environments running in container instances. You can keep Jenkins controller part outside of OpenShift for hybrid usage scenarios and keep slave container instances inside OpenShift container platform. We do provide also a domain-specific language for Jenkins pipelines to simplify OpenShift related tasks. Tekton is a Kubernetes native open source project simplifying cloud native CI/CD pipelines quickly. As opposed to Jenkins, it doesn't require a controller setup. By leveraging custom resource definitions in Kubernetes, Tekton uses Kubernetes own control plane to run pipeline tasks. Tekton is one of the initial projects in Continuous Delivery Foundation. CDF has more than 25 members today, and Red Hat is one of those active members and fully committed to the values of CDF. All right, we have talked not enough today. Let's see some things in action. Today I'm going to demonstrate you a migration story. I'll be using this retail store example. It's currently hosted on Java Enterprise Edition platform on a third-party application server. As a first step of this transformation, I'll be migrating that application from that third-party application server to JBoss Enterprise Application Platform. And the next step will be decomposing that monolith application capabilities into some microservices. So in that state, our application will be decomposed into some microservices partially. I call it hybrid modular. And in a later stage, I do expect that all of the capabilities of that old monolith application converted into microservices. This will be the final state of our application. And today I would like to show you also some of the capabilities of Red Hat Service Mesh. And if you think about serverless and event-driven, would be a next step after converting your application into microservices, but today I'm not planning to demonstrate this serverless part. So the first step is, as I said, migrating application into Java Enterprise Application Platform. I'll be using Red Hat Application Migration Toolkit and some Red Hat CodeReady Developer Studio tools, and also JBoss Enterprise Application Platform itself. So it's a long story. These transformations takes a lot of time in real life. I'll be using some pre-recorded videos to demonstrate this transformation story to you. Let's start. All right, for the first step, I need to download Red Hat Application Migration Toolkit from developers.redhat.com. Once you finish that download, you can run it as a command line interface. So I have my application here under monolith directory. So I give it as an input, and I define an output directory and run my Red Hat Application Migration Toolkit. It's pretty fast, takes a couple of minutes, then your report will be ready. Here we are looking at the report. In this dashboard, you can see what's the cost of migrating this application to Enterprise Application Platform. You can see all of the user points. You can see details of technologies used in that application. You can take a look at EJBs inside your application. Please notice that I gave only the WOR, the binary, as an input. So here you can see also details of the issues, what you need to fix. And Red Hat Application Migration Toolkit gives its advices what you need to fix in your source code. The next step for you would be making those changes in your source code. So another mode of running a Red Hat Application Migration Toolkit is a web application. You can run it as a web application through your browser. You can just upload your application binary or source code into the application, and you can execute exactly the same analysis there. Here I'm checking application migration and also containerization options, and later you can get the same result from this application as well. So once you finish your application migration, the next step would be containerizing it. For that purpose, I'll be using a local environment again, which is CodeReady containers. You need to download it from same site again. Once you download CodeReady containers, you can run a local OpenShift cluster. You just need to type some comments and it will be there. So my OpenShift has a single node and some enterprise capabilities are missing, but it's good enough to develop applications. Let's start with creating a project first. I would need this one, this namespace to deploy my components inside. I would need a database to test my application on OpenShift container platform. My application requires a database, so for that purpose, I'm deploying a Postgres database. Here in my local environment, I picked Postgres from the service catalog. Now I initiated that template and filling the required values. With some few steps, my database would be ready. So there are several options available to deploy components on OpenShift container platform. Using service catalog is the most simple one. Once you deploy your things there, you can use it like in a virtual machine. I just check log and access terminal. The next step, I would like to test my application in my local environment first. For that purpose, I'm using Red Hat Container Studio, which is an Eclipse-based IDE. Inside that one, I have a plugin that I can connect to OpenShift Container Platform to deploy my things or check my things on OpenShift Container Platform. Here I'm connecting to my local CodeReady Studio. I have a local application server deployed here, and I already migrated my application beforehand. Now I can test it in my local environment first. Let's see the application. So as you can see, this is a simple retail application. I have a catalog and I can pick up some items to buy, and later I can check out those items. So let's deploy this application on OpenShift Container Platform. So for that purpose, I'll be using OpenShift S2I capabilities. I have my binary prepared in my local environment. So I need to upload that binary to an S2I image inside OpenShift Container Platform. That one uploads my application binary, placing it in an image template, and prepares and ready to run image for enterprise application platform. We have this capability for other runtimes as well. So my application is ready. Let's test it on OpenShift container platform. The experience should be the same. As you can see, now I can access the same screens from OpenShift container platform. I would like to quick demonstrate OpenShift self-healing capability and uninterrupted failover capability. For that purpose, I would require two copies of my EAP server, 2 instances. So I spin up one more. I start here HTTP request to my application. As you can see, I keep getting HTTP 200, which shows my application is up and running. And now I'm going to kill one of my running deployment pods to show you how OpenShift can heal it automatically. So I'm deleting one of my pods here. As you can see on the right hand side, I keep getting HTTP 200 responses. If I switch back to OpenShift console, I can see that OpenShift is recovering my failed instance. Let's jump to the next stage, which is decomposing my monolith capabilities into microservices. So I would like to talk about my current application first. I have a layered application, so I'm a bit lucky. My front end part is calling backend capabilities through RESTful services. In this example, let me show you my backend service. So this backend service, RESTful service, is hosted by my monolith application. As the next step, I'm going to extract this capability from this monolith application. For this purpose, I'm going to be using a technique called strangling the monolith. Instead of replacing everything as one step, I'm going to incrementally replace it. So I'm going to have 2 macro services, as one for catalog and one for inventory. I already prepared my service, and I'm using Visual Studio Code this time to implement my service. Here we are looking at our Quarkus application configuration. As you can see, we have different configuration for different environments. So let's test this application in Visual Studio Code first. So I start my application in development mode to make some changes live on my code. Here my application is started. So let's check if it's running. As you can see, my inventory service is responding now. Let's debug source code to show you Visual Studio Code capabilities. So I have breakpoint here. My application stopped there. So I can fix my code. If there's a bug, I can walk through my code to understand that problem in more detail. So let me show you the live capabilities. Here we are looking at the front screen of my macro service. Let's make a small change there in my front end. I'm going to be changing my index HTML and put there a small change. So please notify that I'm not recompiling my application, just refreshing my screen. My change is there. So it's joyful to implement code with Quarkus. So the second service is my catalog service. For this time I used Spring Boot for this purpose. I just need to compile it. Similarly, I can run it in my local environment and test it. So it's running on a different port, but this service is also calling my Quarkus service. Inventory data is coming from my inventory service. So just to show you, I'm using the same similar API. So let's replace the current API with this one. So I deployed my applications at this stage on OpenShift container platform. My monolith is still running as the same as my local environment. But I have my catalog service also deployed here. And as you know, I have similar API, same API implemented in this macro service. So let's replace it. So what I'm going to do is I'm going to tweak OpenShift router a bit. Please notice that in this catalog we will have a small difference. So this is the service we are going to replace. So just to show you that difference, here we have an extra product after a joystick. And in my new inventory service, I'm not having same product again. So I need to define a new root definition, but this root definition only for past subpath. I'm just defining a root definition for this subpath. I'm creating it and forwarding this path to my newly implemented service. Let's check how is it working. So yeah, this is the old screen. So let's refresh it to see if other joystick is there. As you can see, it's now disappeared. So we replaced our existing capability. So using this triangular monolith pattern, by the time you will find that monolith application capabilities are retired and everything replaced by macro services, like this example. This is a very nice example that we replaced everything with macro services. This is a nice example of a polyglot application. I have different runtimes, including NodeJS, Quarkus, Spring Boot, and even I'm using different databases. data grid and other databases, Postgres, Mongo as well. But the user experience is still the same. From user experience perspective, nothing has changed, but we totally replaced our technology, old technology with new microservices stack. So this user interfaces helps you a lot to understand topology, and also we have application monitoring capabilities coming with the OpenShift container platform, so you can check container resource usage, and we have even more detailed monitoring capabilities that you can define your custom monitoring metrics inside. So the next step in our story, empowering our microservices architecture with Istio to solve the complexity. Here I'm using another example. This is we have a customer service using preference service, and that goes to recommendation service as a complementary to our cool store application. So I already applied Istio in this case. I start calling my customer service. Here, as you can see, I'm getting different results from my recommendation service each time, because I have currently 3 versions of my recommendation service. So Istio clearly uses screens in Red Hat Service Mesh help you to understand your application topology, and also understand the microservices traffic. Here we can see different metrics, which requests, where are our incoming requests are going, how do we handle those requests. So I'm not designing anything to get this screen. It's automatically produced by Kiali. So in some cases, we need to understand where our service calls are spending most of the time. For that purpose, Jaeger distributed tracing capabilities included. As you can see, our customer service is spanning 3 other services. It's accessing preference and then accessing to recommendation service. And drilling down into these service calls, we can see where we spend or get error. So we have other capabilities coming with Istio as well. Let me show you a routing capability. Here I switch my traffic now only 2 versions of my services. As you can see on the left-hand side, I'm going to accessing to 3 recommendation service, but applying this capability now, I'm just going accessing version 1 and version 2. And I applied this rule as 80 to 20. So 80% of my incoming requests going to version 1, and the other part is going to version 2. So Kiali screens are really great to observe any change in this service mesh, service traffic. So as you can see, now the traffic is increasing on version 1 and version 2. Version 3 is getting nothing at all. So let me show you another example. I remove this virtual service. On the left-hand side, you can see that we start getting results from version 3 as well. Istio is really fast in its operations. So what happens if one of my source versions start failing? Let's create an failure case in my version 2 and see what happens. This is a perfect example of a service chain. Istio comes with circuit breaker patterns out of the box. It will be falling back into other healthy services. On the left-hand side, you can observe now version 1 and version 3 responding, but we are not getting anything from version 2. at all. If we check that service, we can see that we are getting error from that service. This is an out-of-the-box Istio capability. Simply it's getting this error code at the background, but it's not reflecting it to the client side at all. So we can observe this in careless screens, of course. Let me put it back and see that it's also recovering quite easily. All right, on the left-hand side, you can see we start getting responses from version 2 now. All right, great. So these are some capabilities of Istio. Unfortunately, we don't have enough time today to demonstrate everything. Let's start our Q&A session. All right, I'm checking questions here. So my dear colleague Wael is also with us today. I see that he already responded several of these questions, but let's walk through some of these questions. So Mohammed is asking if we have any documents following these demos step by step. Indeed, I push this source code into my GitHub repo. If you search it on Cloud Native, Serhat-Dirik Cloud Native migration, you can find it there, and I can copy and paste the link in chat box. So Ali Imran is asking if there are any practical labs. Yes, actually, we have a dedicated site for this. You can access labs.openshift.com or you can access same workshops from developers.reddit.com as well. These are free workshops, so anyone can register.
Okay, thank you, Ayman Sheikh. Thank you, Sarhat. Thank you for your time. And to everyone else, thank you so much for joining us today. Really appreciate it. We're gonna, of course, send you the presentation via email. Also, we're gonna post it on Red Hat MENA website. Again, thank you so much, and you have a lovely day. Thank you.